All right, ladies and gentlemen, we are talking today about lesson 3.6. 3.6 is proportional and non-proportional relationships. And the big question of the day is, how do we determine if there is a proportional or a non-proportional relationship in our math equations? So, proportional relationships, just by definition, means that a relationship that has the form of y equals kx, where k cannot be equal to 0, is proportional. They make straight lines and they have to go through 0, 0. So that's really what a proportional relationship is. From 3.4 we talked about direct variation. Every direct variation equation is proportional. So there's this little cool thing over here. I'm supposed to slide it over. What else have you learned that has the same? Oh, whoopsies, I already said that. So good thing that we know those things. I'm glad you guys are smart. Let's get on to the actual math. So how do we know if something is proportional? In order for it to make a straight line and to go through 0, 0, my numbers have to be the same from top to bottom. Notice that this is going up by 1, up by 1, up by 1. These are going up by 50, up by 50, up by 50. And what I mean by same from top to bottom, my miles per hour, if I travel for 1 hour, I've traveled 50 miles. That's a 50 miles per hour. If I am using this proportionally, that means if I go for 2 hours, I've gone 100 miles, like the chart says. If I've gone for 10 hours, that means that I have gone 10 times 50 is... I'll wait for you guys to tell me on Monday. That way we know that things are proportional because the miles per hour does not change. So what is the proportion? Well, in this case, if we made this as an equation, my miles is equal to 50 times however many hours that we travel. Hopefully that makes sense to you guys. Let's move on. Alright, so we're going to see if we can find out if this one is proportional as well. Now I want you guys to notice again that we do have a pattern going up by 1, going up by 1, so they were plus 1 every time, right? And over here it's plus 3 every time. Now yes, there is a pattern, but if we look from x's to y's, when x is 1, y is 9. When x is 2, if it were to be proportional, we would assume that x or y would have to be 18, but it's a 12. So this is a non-proportional relationship. And that's kind of hard for us to maybe see, but they are going up in a pattern, but they do, again, make a straight line. They just don't go through the 0, 0 like a direct variation equation does. So if we had to make an equation, we need to figure out how does a 1 turn into a 9 and still have us increase by 3. Now I'm going to give you guys a little trick here. Because this is increasing by 3, I'm going to have y equals 3 times x. Now if I have 3 times x, 3 times x is going to be however we get there. So y times 3 is what? Y times 3, if our x is 1 and our y would then have to be a 3. Now how much more do we have to add to it to make it to be a 9? So 3 plus 6 gets us to a 9. Let's see if that works over here again. 3 times 2 is 6. 6 plus 6 gets us to that 12. So this is actually my equation for this specific chart, I guess, or set of numbers. So notice the pattern that we used. If it was increasing by 3 every time, that's my number in front of the x. And then I just have to plug it in and guess and figure out if it works for all of my numbers. How much more do I add or subtract from that pattern to figure out the rest of my equation? Alright, let's move on. If we have to write an equation for a graph, we're going to use the same type of skills that we just got done using. I like to make tables. Whoop, whoop. Beautiful table there. And oh, looks like someone's ready for Christmas time. It's really colorful, right? So these would be my x's, these would be my y's. This first number we have a negative 1, 1. we have a 0, 2, a 2, 4 from this point, and then a 3, is that 5? 1, 2, 3, 4, it's a 5, 3, 5. Now I'm going up by 1, then I'm going up by 2, then I go up by 1. So we're going to have to make some really good sense of this. This point we missed, right? So what if we plug in the number of 1 and 3, sorry, 1 and a 3. So are we going up by a constant rate every time? The answer would be yes. Do we go through 0, 0? The answer is no. So this is not proportional. It is a non-proportional relationship because it does not go through 0, 0. Oh, I spelled proportional wrong. Don't tell your parents. They might yell at me, or tell them. It's kind of fun that way too. Non-proportional. And we're going to use the same information like we did in the previous example to figure out the equation. So if it's going up by 1 every single time, I'm going to have y is equal to just 1x. So if x is 0, how do we get to a 2 for a y? Well, we had to add 2 to get there. If x was 1, how do we get to 3 for a y? Well, x is 1 plus 2 is 3. So this would be my equation. Now notice that it crosses the y also at 2. I wonder if this number and that number are related to each other. I guess we'll find out soon enough. Now this is exactly the things that you have to be able to do for the assignment. Make sure you do the assignment, and we'll be ready for you on Monday to practice